Thank you very much. Welcome to the webinar devoted to public water transport in the vicinity of Gdańsk. First part of my webinar will be devoted to vessels in the Gdańsk Bay. Second will be focused on the issues of emissions resulting from the combustions of fuels. The new statutory requirements impose the necessity to use low-emission drives, electric or hybrid. These are revolutionary changes. The European Union recognizes some shortcomings in the operation of the electric watercraft market, and that is why the INTERMARE project is supposed to meet them. As you can see, area of interest is located in south part of Baltic Sea. Connections listed on the left are serviced by company Żegluga Gdańska, but there are also other operators. Now during pandemic of coronavirus, number of trips per day are limited. I hope it will be serviced fully in near future, as very important for tourists and visitors of our city. On the next pages, I show you some examples of the vessels. On this photograph, you can see the Onyx Catamaran. It is the largest ship. So-called wide-side ships are an important part of old town landscape and also attraction for tourists. This vessel corresponds well with the historic surroundings. Catamaran allow over 400 passengers to admire the city from a different perspective, from waterways. Yes. For many years, we have a little vessel in Old Town. The connection has only about 80 meters. On photography to the left, you can see the concept of an electric revision of this small ferry. Till recently, an old ferry had a diesel engine. Other connection, but at much longer distance, is realized by Galeon. It is the replica of the medieval pirate ship. It goes to the Westerplatte and back. On the first plan, you can see the ship type of SPJD-7. There are many such ships in Poland, also in Mazurian Lakes. Ships are mainly from 60s. They are takes up to 200 passengers. There is hydrofoil. This kind of ship flies only at good weather. Its engine has special requirements because it has two modes of movement, at low speed and at high speed. High speed ship is above the water surface. Specific mechanical components are stressed at such conditions. This ship takes up 94 passengers. The ferry crossing over the Vistula River is located 19 kilometers in straight line from the center of Gdańsk. The island of Sobieskiego is connected with the mainland. This facility is located in an area valuable for tourism and nature and is intensively exploited in the summer season. Currently, an independent tugboat is used for propulsion. One of the tasks I set myself was looking for energy consumed by vessels' propulsion systems. We would like to give the best solution, a lower cost, more efficient, non-toxic and safe propulsion. That was not an easy task because of lack of technical data related to specific working conditions. For example, how much power we really need. Typically, sophisticated measurement systems should be installed on board. We need a clean propulsion systems. In addition to water and carbon dioxide, undesirable products also appear in the combustion products. Unfortunately, the high temperature of the combustion reaction also causes the oxidation of nitrogen in the air and sulfur in the fuel. Nitrogen and sulfur oxides in combination with water form reactive acids that form so-called acid rain. Places with unfavorable geographic locations and microclimate example, where low wind speeds are particularly vulnerable because of winds in Gdańsk region is a good position in this respect. In the following, we go to the next part of my webinar. I will tell you about the details of the typical diesel drive and emissions issues. Finally, I would like to show results of some calculations done for the two ferries, short distance platform and longer distance vessel. Ships operating in Baltic Sea in the coastal zone are subject to a number of regulations regarding harm of emissions to the atmosphere. In accordance to the provisions of the MARPOL Convention, the areas of sulfur dioxide (SO2) emissions control also apply. The main problem is emissions which are mainly from diesel engines. The figure shows the side view of internal combustion piston engine. The drawing shows content of substrates and products per 1 kWh of mechanical energy received on the motor shaft. The main products include energy, heat, and unnecessary substances. The exhaust fumes are largely toxic. Now I put some explanation related to names of fuels. Diesel fuels are mixtures of hydrocarbon compounds, mainly derived from the distillation of crude oil. These fuels are usually fluidal or even solid. They come under different names. The short names describe the physical properties, mainly the viscosity or type of friction and the sulfur content. The sulfur content of fuel has a significant influence on its lubricating properties. Low sulfur trucks are inferior in this regard. There are some ways to ensure clean power stations for vessels, from investments in systems based mainly on the through cleaning of exhaust gases to systems based on alternative fuels. In the quoted publication, the effectiveness of heavy oil alternatives was compared in terms of unit size, investments, costs, and operating costs. As you can see, the ship owner must take into account many factors resulting from his specific situation. Not an easy task. The slide shows a comparison of carbon dioxide emissions from transport. As you can see, big ships are best. Carbon dioxide, CO2 itself, is a colorless gas that is slightly soluble in water. It occurs naturally in the Earth's atmosphere. On Earth's natural processes, there is 15 times more than human can do. For plants, it's needed to produce carbohydrates. As chemical compound, it is necessary for humans to maintain the acid-base balance of the body. At this point, for comparison, I provide you some balance sheet information about the man himself. Such information is especially important for passenger ships, I think. In living organisms, life processes are described by very complex biochemical cycles. Hydrogen ions take part in the every energy processes of the body's cells, similarly as hydrogen in electric fuel cells. In respect to respiration, we are very sensitive to the levels of carbon monoxide and also sulfur and nitrogen oxides. Especially carbon monoxide is very dangerous as effective in blocking the blood's ability to carry oxygen. This undesirable component of exhaust gas results from combustion of fossil fuels containing sulfur. In order to reduce sulfur dioxide emissions in ports, ship power stations use alternative fuels, and ship owners are happy to inform about it. Scrubbers are used to eliminate sulfur and nitrogen oxides. Unfortunately, at high temperatures of the combustion reaction, nitrogen oxides are also produced. Generally, the nitrogen oxide emissions levels are lower compared to the sulfur oxide emissions. Nitrogen dioxide is the most stable form at room temperature. Changes in molecular structure are accompanied by color changes both in the gas and liquid phases. This is a large class of chlorinated hydrocarbons. Chlorinated hydrocarbons. They are harmful to ozone layer. They have typically been used in past in closed refrigeration circuits. They are usually inert gases or low boiling liquids. Such cases, if released as a result of unsealing, they migrate to upper layers of Earth atmosphere. Under the influence of ultraviolet radiation from sun, they contribute to decomposition of significant amounts of desired ozone, O3, gas form of oxygen. And now we are back to non-ferry platform and its physics. The platform itself is held on course by a powerful steel rope wire. The weight of ferry platform is about 100 tons if loaded. And now I present example a calculation of theoretically consumed energy. I made an elementary energy balance for a system. I assumed lack of resistance to platform movement in the water and to the rope, drive efficiency, time needed for acceleration and deceleration or braking, and basic calculations are to estimate drive power for the platform. The ferry typically makes 60 journeys per day. Assuming that during braking energy is lost, that amount of energy is 45 kilowatt hours per day. The fuel consumption is typical diesel engine is given from Volvo's technical data. However, a slightly higher fuel consumption was adopted for the calculations. Such estimation should be verified by recording the instantaneous engine power. This would be an indication of the possibility of optimizing the drive and its power supply. In the case of a slow motion and short distance floating platform, we assume no resistance to motion. However, the drag to float is the main cause of fuel consumption in ships. It highly depends on manufacturers. Also, the condition of the hull surface. Generally, the issues of fluid mechanics are very complex. Special tools were developed to support design the hull. The sample simulation tool allowed to and optimize shapes based on fluid mechanics and modern computational techniques. In a second example, more sophisticated calculations was done. We did simulation of ferry connection, which is realized from an old town Gdańsk to Sobiszewo Island. This vessel takes up to 50 passengers. Distance is about 16 kilometers one way. We took into account more advanced formulas related to flow resistance. We calculate the amount of energy needed for round trip between Gdańsk and Sobiszewo. We did some simplification. For example, we assumed constant amount of energy for acceleration and deceleration processes and assumed ideal weather conditions. It seems to be possible to realize full electric propulsion system, I think. It's worth to note that Gdańsk Bay area neighbors habitat protected areas depicted in European Ecological Network, Natura 2000 in Poland. So maybe also water tramway, similar to the road vehicle in town, could be electric. Thank you very much.